The development and travels of your average sperm involves a lot of different places and a lot of different steps. You would like to think that they are all born nicely at these seminiferous tubules in the testis here and eventually appear outside the urethra. But there's a lot of steps in between, and in the next few slides we're going to review those steps. Let's look at the classic histology of a testicle and follow the travels of the sperm to the outside of the male penis. Most of the cut section of a testicle is actually relatively soft, delicate seminiferous tubules separated by small amounts of connective tissue as well as thicker amounts of connective tissue. The whole structure is covered with a fibrous capsule. And you will also see an area, if you cut through a testicle, in which the tissue looks a little bit denser, which is regarded as the mediastinum testis, or RETE, R-E-T-E testis. Let's take a look at the outside of the testicle, and remember there's about 3 or 4 layers here as well, named in Latin. The most outer layer is actually a lining of mesothelial cells, just like we saw in the pleural cavity, the pericardial cavity, and the abdominal cavity, which is the same lining of the abdominal cavity. It's mesothelium because that's where the testicle comes from. This is the tunica vaginalis. It is lining the testicle itself, but there is another lining in the scrotum called the parietal tunica vaginalis, just as this layer of mesothelial cells is the visceral tunica vaginalis. The chief thickness of the testicle capsule is the tunica albuginea, and as you can see, this is chiefly just fibrous tissue, collagen, and fibroblasts. Theoretically, there's another layer before you get into the seminiferous tubules, which has a lot of blood vessels, like here and here. It's the deepest part of the tunica albuginea, which is called the tunica vasculosa. You can see some vessels here. And it's not as well defined as the other tunics, but nevertheless, when you go into the very deepest parts of the tunica albuginea, you'll see blood vessels, and that's called the tunica vasculosa. So much for the capsule. Let's look at the seminiferous tubules themselves, which is the vast majority of the substance or the parenchyma of the testicle. These are all seminiferous tubules. There. They are kind of nicely separated by thin bands of loose fibrous connective tissue, and the maturation of sperm goes from the base towards the lumen. And there are certain cells which are commonly seen, and there are certain levels of development which are very rarely seen. So let's take the easy ones first. When you see nice and round dark nuclei near the base, those are spermatogonia. The vast majority of the round dark cells, many of which contain mitotic figures, are primary spermatocytes. There's one. Oh, there's probably one. Probably there's one. The dark cells with ropey nuclei, often mitotic, are primary spermatocytes. The round cells near the base of the tubule, where the connective tissue is, are spermatogonia. Every now and then you will see nuclei which are not round, but they're a little bit spindly, and they're oriented with 90-degree angles with respect to the base. These are your Sertoli cells. They support the tubule in more ways than one. They're also called sustentacular cells, and there is a Sertoli cell there. Notice the Sertoli cell nuclei, like there, and there, and there, and probably there. They are not round, and they are not as dense as the primary spermatocytes. There is a cell called a secondary spermatocyte, but it is very rarely seen in human tissues. And when you think you see one, you're probably wrong. So for the most part, let's ignore the secondary spermatocytes. We all know what a mature sperm looks like. It looks like this. It has a very, very, very tiny slit-like nucleus and a tail, which is usually beyond the resolution of light microscopy. And anything in between, like perhaps here, can be called spermatids. So there is probably a spermatogonium here. This has a good chance of being a sustentacular cell because it's lighter and it's potato-shaped rather than round and dark. The cells in mitosis here are very easily recognized as primary spermatocytes, as well as most of the other dark round cells. Most of the cells in the seminiferous tubule are primary spermatocytes. These cells more towards the lumen, which still have a significant amount of cytoplasm, are called spermatids. And last but not least, whenever you see cells that look like classical sperm, like right here, a little head and maybe a little tail, those are your mature spermatozoas. The interstitium, or the area of connective tissue between the tubules, has chiefly some fibroblasts, but in addition, the most important cell of the interstitium, and this is probably one right here, is a Leydig cell, and the Leydig cells secrete testosterone. And often, if you're lucky and you have a really high power microscope, maybe you can see little crystals of testosterone in them. And there's probably a couple Leydig cells there, and there's probably one there. Otherwise, the majority of the cells in the interstitium between the tubules are simply the cells of fibroblasts which support the tubules. There might be a couple Leydig cells here. They're much more common in old age, and sometimes they're harder to see. But any cell in the interstitium which does not look like a fibroblast and has a good amount of cytoplasm, often a little bit redder than the rest of the cells, and certainly not spindly, is probably a Leydig cell. In addition, if you could see a couple tiny little crystals in here by zooming way up, then you know it's a Leydig cell. So much for the capsule and the seminiferous tubules, which is the vast majority of the testis. Let's now go into an area which is referred to as the mediastinum of the testis. And the mediastinum of the testis, as you could guess, is kind of in the area where the testis is cut, and you can see it's a little bit more fibrous. And the mediastinum of the testis, generally called the rete, R-E-T-E testis, because it looks like a little network, looks exactly like this. The epithelium is extremely flat, certainly maybe cuboidal or low cuboidal, and it is lining areas which are rich in fibrous tissue and blood vessels. This is a classical appearance of a rete testis, also known as the mediastinum testis. Now, I want to tell you something that we may or may not see here. You know this is an artery. You know this is an artery. You know these are ducts lined by columnar epithelium. There is a series of tubules between the classical seminiferous tubules out here and the rete testis, which are called the straight tubules. And I don't think we're going to find any in this one, and it probably doesn't matter. But just remember, if you see tubules in the testis that are not part of the mediastinum of the testis or rete testis like you have here, and they're not seminiferous tubules, but they're lined entirely by Sertoli cells, then you know that those are the straight tubules or the ductuli recti. And you know that in this tubule you have a lot more than just Sertoli cells. There's a lot of spermatogenesis going on here. But just as we close off, you can see that these are probably all mature sperm. You can see the majority of these cells are primary. spermatocytes. These could very easily be spermatogonia. This cell here is a Sertoli cell. Here's a Sertoli cell. And if you ever see tubules which are lined by 100% Sertoli cells in the testis, those are the ductuli recti, or straight tubules. That's it for the testis. Thank you very much.